Let's give it up for the next speaker, Thibaut Sardan from Parity/Polkadot. And I hope he's going to tell a little bit about parachains and how that relates to smart contracts and stuff like that. So please give Thibaut also a warm round of applause while he sets his things up.
Hi, everybody. Thanks for being here. Thank you. Because I couldn't see who of you is a developer, I would like you to raise your hand if you are a developer, please. Oh, we do have a lot. Who of you has ever heard about Polkadot? Wow. Who of you has ever, because you're so many, who of you has ever heard about Substrate? A bit less, that's perfect. That's exactly the right audience. For those of you who didn't see, so there's so many people who heard about Polkadot, a lot less who heard about Substrate, and that's really good because today I'm going to talk about both, and I hope that I can make it clear for you what is each. So I'd like to start with a Igor has oh yeah, I have to, is that fine? Yeah, that works. So I'd like to start with something we keep in mind since the time we started to build Polkadot and later on Substrate. We think that specialization breeds optimization. It means that when you do one thing, or when you do multiple things at the same time, usually when you do one thing, you do it good, better, and you optimize it. And when you try to do too many things at the same time, you don't do it overall very well. And we really think that, well, it's probably better to do one thing and to do it well than to try to do everything. And this brings us to something that we think also that one size doesn't fit all, which means that there is no one blockchain that can do everything. Today, and in the past years, we've seen so many different blockchains that do many things, and there's not one that does it perfectly. We have seen some, for instance, for Zcash, they do privacy things very well. Then there's Bitcoin, they do, well, Bitcoin, you know it. Then there's smart contract for Ethereum. There are many other smart contract platforms that try to do different things, but there's no one blockchain that works for everything. So I took this very nice image from Robert Habermeyer, which is one of the co-founder of Polkadot. He says all these chains, these ecosystems, they're all like these bubbles. They don't really talk to each other. They're all like in their own bubble, and you cannot out of these bubbles make one big, right? They are not really strong together. They are strong like each bubble, and sometimes they collide, but they never merge, and sometimes they even pop. And so we see a fragmented landscape. Those chains, except if they use the really cool bridges from Igor, usually they don't talk to each other. They don't exchange, right? There's no bridge. It's really hard to let them talk. And in the end, what you do, or what people do, is using centralized exchanges, for instance, if you want to swap some coins. But that's a problem because what we want to do is decentralize things, right? That's why we're here. So why are these blockchains different? Most of the time, what these blockchains have is, for instance, Bitcoin, it started with proof of work. It's the consensus that worked well. That is, well, consensus is the Nakamoto consensus, but it's proof of work. And then the second generation, like Ethereum, still use proof of work, but like when we hear about third generations blockchains, we always talk about proof of stake. So this is something that differentiates the different blockchains. The other thing, and maybe most importantly, is what we call the state machine. Why does a block, or why does a transaction in a block makes the state evolve, right? Why do, when I call a smart contract, the smart contract does things on its storage, and then the state evolves? So this is the heart of each blockchain, and each blockchain has his or her his own state machine, right? This is why we have so many different blockchains. And so we see these blockchains, and we really want them to be interoperable, to talk to each other, and this is why we built Polkadot. So most of you guys know about it. I'm going to talk a bit about it, but I will go deeper in what came out of this. So we've started building Polkadot it's been more than a year ago, and what we want to do is let these blockchains with different state machines, with different consensus, talk to each other. So this is built in the protocol. We have interoperability so that they can exchange messages and not only tokens. So we want to support also other chains, such as Ethereum, for instance. That's pretty easy because it's smart contract, it's the smart contract, the EVM is Turing complete, so you can do whatever you want. So we can have bridges and eventually bring these old blockchains to these Polkadot network. We also want, or we can have, public or private blockchain. This is not a problem at all. But what I said just before is that we want these blockchains to exchange not only tokens, but messages, right? Like messages is a superset of tokens. If you can exchange messages, you can exchange token. If you want to exchange token, you can. It doesn't mean that you can exchange messages, right? And so this is what we're building. This is one of the key point of Polkadot. It's different blockchains built in this network that can talk to each other, and it's built in the protocol, and it's decentralized, of course. That's the thing, right? So there's one more point which is really important and interesting, is that every time you build a blockchain, you have to build the community, you have to build the security, right? Like you have Ethereum, you have the miners on Ethereum, you have the miners on I don't know, like Monero, Bitcoin. All these guys have built a community, have built some miners to build the security on their own blockchain. And if you want to build today a blockchain, you will have to do the same. And that's a problem, because it's actually pretty hard to build a community. So today, for instance, on proof of work, it's pretty easy. You have a given amount of hash power, for instance. If you're mining, or if a miner is mining for a bit for, what do I have here? 70% Litecoin and 30% Zcash. Well, everything that you do not have on Zcash is actually like you're lowering the security of some network if you don't use your hash power on there. It's not shared. And thanks to POS, proof of stake, you can actually have validators that validate on several chains at the same time. And this is something that we're using, of course. We call this pooled security. And it means that when you build a blockchain that is in Polkadot, you can benefit from this pooled security. You do not have to care about building your own community, bringing your own security to the network. It's already there. They're all validators that will be dedicated to your network, to your parachain. Parachain is a blockchain that is in parallel, because all these blockchain on Polkadot are basically doing their job in parallel. There's one side effect, a nice side effect to this parallelization is the scalability. Why we built Polkadot is to have those blockchain interoperable, but because you have all these chains, this parachain in parallel, they do their work in parallel, and when they want, they do talk to each other, but they don't have to. It means that the overall throughput of the network is really increased. And this is, of course, something that well, if you get it, you're happy. So this is a 10,000-foot overview of how it looks like. So I was talking about parachain, different parachains, and these are, like you can see, they are different. They are around a relay chain. This relay chain is one of the heart of the Polkadot network. It is a blockchain that is responsible for the validators. It is responsible to relay the messages between the parachain. And you can see on the bottom right, there's an Ethereum bridge, which brings basically the ordered chain, the second generation chains, to this network. Igor is interested. I said the word bridge. So we were building Polkadot, right? We were, okay, at Parity, we've built tons of chains. We've built, so the founding team of Parity has built the CPP implementation of Ethereum, and then we moved to Parity Ethereum, which is in Rust. And then we have the BTC, the PBTC it's called, it's the Bitcoin implementation. And now we were yet building another client for another chain, which was the relay chain for Polkadot. And we thought, wait, we've done this so many times. Every time you have to build the same thing, basically. And for some of you who are developers, you know that it's really bad to copy-paste or to take some code and just duplicate it. What you should do is actually make it generic and generic enough so that you can reuse it, but use the same code everywhere. And that's what let us build Substrate. So Substrate came really naturally, where we were thinking, okay, we're gonna build another client, and now actually we're gonna redo everything again, and let's do it well. Let's do it like build the basics and use it to build our own Polkadot chain. The thing is, this is not only for us. You can use this. It's really for anybody who wants to build a blockchain. So the goal is the goals is to have a customizable framework that basically gives you everything that you need that is essential to have a blockchain, but lets you the flexibility to use some modules so that you can basically pick what you want, just like building out of Lego, right? You have some modules that you can pick and use and some other that you don't need to. And then on top of that, you can build the heart of the blockchain, what I talked about earlier before, the state machine. So what we wanted to have also is to have a light client. So inside the protocol, it's really light client friendly, so that basically you can as a user get on top of the chain really easily with a mobile, for instance. We have built-in governance. You might have heard about it. I will not talk about it today too much, but we have some experts here, so if you want to talk about it, that's not a problem. And Substrate, as I said, it's really different than Polkadot, right? It's like the framework, the base that we use to build Polkadot. But the thing is, you can also use it to build a parachain, and that's where it gets really, really interesting. If you build a blockchain on top of Substrate, it will be really easy for you after that to basically plug it in to Polkadot network. And of course, as I said before, that's how we built it, right? Substrate. It came out just because we were thinking, okay, we have to build Polkadot, and now let's actually build Substrate. So we are using Substrate today, so it's not just something that we built for people to use. It's actually doing dog feeding, right? So now I'm going to get a bit more technical. Depending on how you're sleepy, I might go quicker or not. So everything is architected on WebAssembly. We take advantage of this. There is a really cool article built by, written by one of our developers, which is called Why WASM. WASM is the short name for WebAssembly. So we build everything on P2P, which is a really cool networking protocol from Protocol Labs. We have done a Rust implementation of it. And of course, we built our client in Rust because we love Rust. And there is also another client in JavaScript built also by one of our developers. So this is a really nice overview showing you that basically so in Substrate, that's what you get for free when you use Substrate. You get the networking layer so that your client can talk with each other using P2P, and then there is a consensus that basically decides on what can be on chain or not, and this is the runtime. And the runtime, it is on chain, and you can see what it has inside. Like it has tons of things that you can use. This staking, slashing, parachains, so saying, okay, what parachain are allowed to be on the network, etc. And all of this, you get it for free when you use Substrate. So you get the RPCs, you get the networking, you get the database, you get like tons of things. And we did it because, again, we needed it, so why not give it for free? So where we are now regarding Polkadot, I go back to Polkadot now. where we're now. So we've started, we've released POC 1 and POC 2 in the past months. POC 1 added governance, staking, basic UI, and a forkless upgrade. I didn't talk too much about this. This is a really, really cool feature. Ask me a question about it if you want, so that I know if you're interested in it. Otherwise, let's forget about it. But that's a really cool feature, and this allowed us actually to go from POC 1 to POC 2 without any fork. So even if you have clients that are not updated, you will not have a fork on the chain once you update it. And we went, as I said, from POC 1 to POC 2 using this. The POC 2 is out since a couple months already. It adds Sleep P2P and the co-finalization of none. You can read that yourself. And then we're about to have a POC 3 out, so hopefully before the end of this year, and it brings a really cool new consensus called Grandpa. You can read about it also online. And then since from next year and the year after, no, sorry, only this year. Next year we'll have POC 4, etc. So we'll bring the cross-chain messaging and we'll make it everything even more stable. In parallel, of course, we keep building things to help developers build around substrates. So this is mostly around WASM. And yeah, again, that's really something we want to push forward to build on top of Substrate, because it's a really cool framework. If there is one thing you have to remember, if you want to remember and go see our page, parity.io/substrate, from there you will have all the information that you need. I think that's it. Thank you.
Questions?
Hi, thank you very much for the presentation. Do you mind to go back to the slide with the layers? Yeah. Does it have a virtual machine? Because I quite don't understand, what does WebAssembly have to do with it? Okay. Is it compiled WebAssembly to deploy smart contracts? Or?
So basically, the chain, the runtime is in WebAssembly. So it means that you can use, for instance, Rust or C++ to build the runtime. So basically, you build the heart of your blockchain, and this will be on chain, or this will be shared among.
All right.
So there's no virtual machine, right?
Okay. So, can you talk a little bit about the virtual machine? What kind of virtual machine is it? Like stack-based virtual machine?
Since I'm not a developer for this, I would not talk about it. I would actually rather point you to this really cool article written by one of our dev, why we chose WASM, actually, why we chose WebAssembly.
Cool, thanks.
There are tons of good arguments, and I wouldn't be able to tell them right away.
Right.
When did you guys settle the debate between Shaft and Grandpa? Yeah, it's so long.
The question was, what about the Shaft and Grandpa?
Yeah, I was just wondering if you landed on Grandpa yet, or if it's still up for debate. It's contentious at work, though.
If we chose, I thought, no, I think we did choose. I think it's Grandpa. Yeah, I read that. Oh, really? Okay, there is another debate. Okay. My problem is I prefer Grandpa, but I remember only what shafts mean. I never remember what Grandpa means. So, shaft is shared ancestor finality. Yeah, whatever. That's a really cool consensus anyway, and we will, I think, publish about it again soon when we have POC 3 out.
Yes, coming up.
Thank you. I'm not a developer, so maybe that question is a little bit stupid, but since you have in the runtime, you have smart contracts, does it mean that if I plug a non-smart contracted blockchain into Substrate, it will be able to use smart contracts? Or, I mean, for example, Bitcoin or?
So Substrate itself doesn't have the runtime. Basically, it gives you everything around it, and you can do whatever you want with your blockchain. So you can have a non-smart contract blockchain. You can have a blockchain that does, like, I don't know, just like Bitcoin, for instance, based on UTXO model. You can have, we are building right now a blockchain. We have actually live on testnet a blockchain based on WASM smart contract, so that you can write smart contract in WebAssembly. So this is really up to you. Substrate gives you all the tools, but lets you free to use them or not, and to do whatever you want with your blockchain.
So I basically achieve interoperability within all substrate networks, but not necessary to other networks that are not, like, for example, Bitcoin.
Yeah, so Bitcoin, we could eventually bridge it, just like we showed on, which slide was this? We were showing a bridge with Ethereum. So Bitcoin doesn't have smart contracts, so it's not that easy to build the bridges just like Igor builds. So you have to have some kind of validators in between, etc. It's not the easiest. It's not the easiest to do in a decentralized manner. And so we can bring these guys to the Polkadot network. Whether or not we'll do it or someone will do it, that's another question.
Does it give you a confidential
Wait. So that
for the
video.
Does it give you confidential transactions?
So you can. So we really, I mean, that's something we really like anyway. So I'm pretty sure we'll have this. So you can, most probably, you will have a parachain that is dedicated to privacy, such as Zcash and stuff like this. So, like, it does not embed it, but it is, you can build it inside the runtime. This is basically, this would be the heart of your parachain to put.
Okay, and this the substrate ecosystem does give me some sort of interoperability between different sorts of confidential transactions. Then this is
Yes,
the
why
idea,
not?
basically.
Why not? I mean, it doesn't have to do with confidentiality, right? It gives you interoperability between whatever you want to build. So it just embeds in the protocol the interoperability. But what you do on your parachain is really up to you.
Okay, I see. It's a long wait.
I have one in the front.
Last two questions.
Okay, the obvious one. Can you talk about forkless updates?
Oh yes, thanks. I would love to. So there's a really cool feature thanks to WASM. So WASM is basically kind of how should I explain this? So there's a binary. So it's kind of, you can take it and let it run if you want. And so this is on-chain. So when you do an upgrade, you have, for instance, some clients that are updated, like they know that we will have a fork at block 10, for instance, and that we have to use a new runtime. And then we have this old client that did not update, and that doesn't know that there's going to be a fork actually at block 10. And when block 10s arrive, there's this new client, they see that the runtime has been changed, because basically this WASM runtime has been updated on chain. And this new client, he knows that, he sees that, and he will actually not have to run the WASM interpreted. He has it already natively because they are updated. But this old client, sorry, will see that there is a new runtime and he doesn't have it. He's not up to date, so he doesn't have it natively. He will be able to use the interpreter of WASM so that he keeps being on the same chain without any fork. And this is really awesome because it allows you to have a forkless network. And some of you might know, but we're trying to do some updates, some upgrades, or some forks on Ethereum. And this is really a big pain because we have so many different clients today on Ethereum. And when we do a fork, not all the clients are when we do, let's say, an upgrade, not all the clients accept this upgrade, and some start doing some forks and building some other chains, and this is really hard.
But that is part of the consensus, basically, part of the governance, basically, in Ethereum, right? And you exclude that,
So we
basically.
do, yeah.
So you have another governance model.
Exactly. We have governance also built in the protocol, and this allows you to basically propose some updates, etc., and let you vote to accept or not the updates, etc. This is already also a very big topic.
Last question, anyone? No? Then give Thibaut a warm round of applause.